Genius Kids. Cultivating love for learning.
Chapter 5. Acids, Bases and Salts. Knowledge acquisition. Acids are those substances which produce hydrogen, H+, ions when added to water. Bases are those substances which produce hydroxide, OH-, ions when added to water. Salts are the ionic compounds that are formed by the reaction of acids and bases. Discussion. Jack: I am not in a mood to study today. Tell me only one good reason for reading this chapter. Susie: do you know what is vinegar that you eat, an acid or a base or a salt? Jack: no, Susie. I know. If you also wanna know, then come, let's read this chapter. Acids. Definition. Acids are those substances that produce hydrogen ions when added to water. They are sour in taste. Classification of acids. 1. Types of acids on the basis of their source. 1. Organic acid. Acids produced by plants and animals, except hydrochloric acid, are called as organic acids. 2. Mineral or inorganic acids. Acids prepared from naturally occurring minerals are inorganic or mineral acids. Examples of organic acids include citric acid, lactic acid, uric acid, etc., and those of mineral acids include nitric acid, hydrochloric acid, etc. 2. Types of acids on the basis of their existence or occurrence. 1. Natural acids. Acids obtained from natural substances are called natural acids. 2. Artificial acids. Acids that are produced artificially or synthetically are called artificial acids. Examples of natural acids include citric acid obtained from oranges and lemons, and those of artificial acids include nitric acid and hydrochloric acid. Natural sources of acids. Common acids and their formulae. 1. Sulfuric acid, H2SO4. 2. Hydrochloric acid, HCl. 3. Nitric acid, HNO3. 4. Acetic acid, CH3COOH. 3. Types of acids on the basis of their strength. 1. Strong acids. These are those acids that release all of their hydrogen ions when added to water. For example, sulfuric acid, nitric acid, etc. 2. Weak acids. These are those acids which only partly lose their hydrogen ions when added to water. For example, oxalic acid, acetic acid, etc. 4. Types of acids on the basis of their concentration. 1. Concentrated acid. This is an acid with more acid content and less or no water. Example, 90% H2SO4 is a concentrated acid. 2. Dilute acid. This is an acid with less acid content and more water content. Example, 10% H2SO4 is a dilute acid. Properties of acid. Sour taste is the unique property of all the acids. They can conduct electric current. They are corrosive by nature. This is the reason they can't be stored in metal containers, because they corrode iron and aluminum. Sometimes an orange layer can also be seen on glass containers. Last but not the least, students. I will tell you the last point. It was long ago when my grandfather was a young child and working in chemistry lab. He, by chance, put a drop of hydrochloric acid on his clothes, and do you know what had happened? His favorite kurta had got a hole. So moral of the story is always be cautious with acids as they can burn. your skin or your clothes. Applications of acids. 1. Sulfuric acid. 1. It is a powerful dehydrating agent. 2. It is used in production of fertilizers. 3. It is used in car batteries. 4. It is used in paints, plastic, drug manufacturing. Note: sulfuric acid is known as the king of chemicals. 2. Hydrochloric acid. 1. It is the most common acid of laboratory. 2. It is used for descaling, that is cleaning of boilers. 3. Aqua regia, that is 3 parts concentrated HCl and 1 part of concentrated HNO3 are used for dissolution of gold or platinum. 4. Bleaching is also facilitated by this acid. 3. Nitric acid. 1. It is used in manufacturing perfumes. 2. It is used in manufacturing dyes. 3. It is used for metal purification during their extraction. 4. It is used in production of explosives, for example in production of RDX, research development explosive, and TNT, trinitrotoluene, bases. Definition: substances which give us hydroxide ions, OH-, when we dissolve them in water are called bases. Examples of bases include sodium hydroxide, potassium hydroxide, etc. Classification of bases. Types of bases on the basis of their strength include: 1. Strong bases. Those bases which dissociate completely when dissolved in water are called strong bases. For example, sodium hydroxide, NaOH, and potassium hydroxide, KOH. NaOH and KOH are called caustic soda and caustic potash, respectively. 2. Weak bases. Bases that dissociate incompletely in water are called weak bases. Examples of weak bases include magnesium hydroxide, MgOH2, and calcium hydroxide, CaOH2. Water-soluble bases are called alkalis. For example, sodium hydroxide, barium hydroxide, etc. All alkalis are bases, but all bases are not alkalis. Properties of bases. Bitter taste is the unique property of all the bases. They are soapy. They have the ability to corrode our skin. Just like acids, they can conduct electricity. Applications of bases. 1. Sodium hydroxide. 1. It is the most common base in a laboratory. 2. It is used in manufacturing medicines, soaps, detergents, plastic, rayon, paper, pulp, textiles, etc. 2. Ammonium hydroxide. 1. Used in fertilizer industry. 2. Serves as an ink stain remover. 3. Calcium hydroxide. Calcium hydroxide in solid form is called slaked lime. 1. It serves as an antidote for acid poisoning. 2. It helps in bleaching powder preparation. 3. It neutralizes acidity of soil. 4. It is a water softener. Indicators. Indicators are those substances that can change their color with respect to the acidic or basic nature of the target substance, that is the substance to be tested. Chemically, an indicator is a weak organic base or an acid. Indicators are of two types. 1. Natural indicators. 1. Litmus. Source: lichen. Colors: it is of two colors, red and blue. Form: can be in the form of solution or paper. As an indicator: for acid, blue to red. For base, red to blue. 2. Turmeric. Source: turmeric. As an indicator, turns from orange to red for a base or basic solution. 3. China rose. Source: China rose flower petals. As an indicator, magenta to green for bases or basic solution. 2. Synthetic indicators. 1. Phenolphthalein. As an indicator, colorless for acids, pink for bases. 2. Methyl orange. As an indicator, orange for acids, yellow for bases. Salts. Salts are formed when acids react with the bases. The complete reaction between an acid and a base to form salt and water is called neutralization. Substance which is not an acid neither a base is called as a neutral substance. For example, common salt, sugar, oxygen, water, nitrogen, etc. Neutralization can be depicted as an acid plus base, salt plus water. For example, HCl plus NaOH, NaCl plus H2O. Critical thinking. Antacid containing baking soda is used to neutralize acidity. Waste can be neutralized by slaked lime. Continuous review. Acids are proton donors and bases are proton acceptors. Aqua regia, 3 parts concentrated HCl and 1 part concentrated HNO3, are used for dissolution of gold and platinum. Sulfuric acid is the king of chemicals. Indicators are those substances that can change their color with respect to surrounding acidic or basic medium.
Like, share and subscribe.